Joining us right now on the Voices of Wall Street is Rick Fulop. He is the co-founder and CEO of Desktop Metal, a 3D printing company that's a first mover in what's being called additive manufacturing 2.0. Rick, thanks so much for joining us.
Thank you, Dion. It's a pleasure to be here with you.
And a pleasure is all mine and all ours here at Voices of Wall Street. So, Rick, tell me, let's just get started with this. What is additive manufacturing 2.0? And for those who don't know, what is Desktop Metal?
Yeah, so Desktop Metal is a company in Massachusetts that's revolutionizing the way that you can make parts with metal 3D printing. And metal printing's been around for a long time. Legacy technologies used to make parts with this process used either lasers or sequential type of binder jetting, and those techniques are relatively slow, and it led to parts that were traditionally a lot more expensive than conventional methods. So the only benefit to additive was either shape complexity or more sophisticated components that would have been expensive to make with casting or machining. And one of the things that exemplifies what we do is we've turned that technology into something very affordable that's able to produce parts roughly 100 times faster than legacy systems using lasers. And as a result, the parts are about 1/20th the cost, which is a dramatic change. And that enables you to, for the first time, go to market with metal printing for a much broader set of processes. So the benefits is that it's cheaper than machining and cheaper than casting up to a very large number of units, and it enables you to really amplify the type of applications that can be pursued with additive.
Mm. And yeah, you guys went public this month via a SPAC. Why was that the right opportunity? Because a lot of folks that we interview here on this program, and you see it across the market, SPACs are kind of everywhere. Why was that the right choice for you and your company?
I mean, we would have traditionally gone public with a conventional IPO probably 2 years from now, but I think the pandemic created an opportunity for folks to do a roadshow virtually over Zoom, and people have now used. Look, we're doing this interview completely virtual, whereas maybe in the past we would have gone to a studio, right? So I think that this has normalized the ability to interact over video, and I think that combined with a lot of capital that got built into the SPAC market created an opportunity for us to really accelerate our plans to go public and also develop our opportunities in the consolidation side. There's a lot of companies in the additive space that are private today that are good opportunities for us to partner with. So.
And talk about that, because obviously, M&A is, I think, a really big theme and topic right now. You guys just have gone public. I think it's been about 2 weeks since you've officially been on the market, and you're kind of already talking about opportunities. How do you plan to explore that space?
I mean, we have an organic business that's thriving, and it's growing very aggressively. This year we have a really great runway to expand it, and I would say the opportunity on the M&A side is that our industry's gone through a transition period. The first phase of additive during the first 25 years was really about tooling and about sort of design, form, fit, function models for the early stages of engineering. They weren't about end.
That was additive 1.0.
Yes, they weren't about parts that end up in a product. They were more about the designer of a part being able to see what it would look like in real life and having a prototype. And really, in a program, when you're going to make a product, I would say maybe you spend 2% or 1% of your spend on the prototyping, and maybe you spend maybe 2 or 3% on the tooling. But the bulk of the spend is usually in the end-use part and in the spare parts. That's where 95% of the money goes to. And in the first phase of additive, the material properties that you could get out of the process and the throughput that you could get out of the process was not good enough to really compete with conventional manufacturing. And so you had a series of companies that kind of had a run up during that phase, over the past 25 years. And really that party ended at the turn of this past decade. maybe roughly 8 years ago, 6 or 8 years ago. And, you had a quiet period where a lot of the innovation in our market has come in the private sector, primarily out of companies like us, which were venture funded. I mean, we had raised about $430 million from companies like Ford and Koch Industries and Google and folks like that ahead of this transaction. And we were able to develop technology that is far exceeds what people have done in the prior generation of companies. And I think that is an opportunity for us. When you talked earlier about M&A, most of the exciting things happening in our market are in the private segment. If you have roughly $12 billion, this is an industry that's $12 billion today, that's projected by the end of the decade to grow to $146 billion. So it's of that 12 billion, that's 0.1% of the manufacturing industry. So almost nothing is additively made today. So this is equivalent to where the semiconductor industry was in the early 70s, thinking that that by the early 80s it was going to be $100+ billion business. But I think that's an interesting analogy of where we are from a timing point of view in this industry. So that the exciting part here is that out of that 12 billion, there's roughly about 2 billion worth of technologies and applications that I think are really interesting companies that could fit well in our business. However, our core business continues to be our organic growth behind our products, which are market leading.
So, Rick, let me just switch up a little bit, because you mentioned a couple things that I thought were particularly interesting and wanted to drill down on a little bit. I mean, one, do you guys just have a big cash pile? Because you talked about some of those partners that you have with particularly deep pockets. And then the second question I'd ask you is just, how do these potential acquisitions boost you guys? Because as you talked about, you are really already a leader in the field, and you guys are out here with first mover advantage in the space, in this AM 2.0 space.
Absolutely. Look, we have roughly $4.5 billion in currency between cash and stock today, about $600 million in cash. And I would say, we're going to be very thoughtful and constructive of any moves that we make, where our core focus is our organic business. But I think we do think there's a huge opportunity, considering that, if you believe that in our lifetime, 3, 5, 10% of parts will be additively made because of all the environmental and lightweighting and all the benefits that this technology brings, that could be a massive business, considering manufacturing is $12 trillion. We're in the early days still. I mean, when I say that we're in the 1970s of semiconductor equivalent, if you make an analogy from semiconductors to where we are in additive, this is like 1992 for networking or 1972 for semiconductors, equivalent to where we are today in this industry. So it's projected to be broadly used, and I think that's you could totally see a company like us being 10 to 50 times bigger than where we are in terms of revenue.
That's big. Yeah. And, a lot of people, I think about additive in the manufacturing, or sorry, not in the manufacturing, but in the auto space, right? In terms of cars, even electric vehicles. I'd love for you to talk a little bit about that, specifically electric vehicles, but also space, robotics. Tell me about the other industries that you guys can touch, and what are you doing in those right now?
Super horizontal technology. It actually touches so many industries, everything from every modality of transportation, whether it's air, land, and sea, in space, consumer goods, healthcare. It's a huge medical applications in additive, in propulsion, in mining, in oil and gas, machine design, manufacturing tools. So there's a very broad horizontal base of products. You talked about automotive. It's roughly about 20% of our business, and we work with all the major vehicle OEMs: Honda, Nissan, Toyota, Ford, BMW, Volkswagen.
Oh, and you have deals with all those guys already.
they use our products or development programs with us. So yeah, so we've got already a great base, great customer base in that space that's expanding and evolving. Now, I think just as exciting. I mean, I don't like businesses that have account concentration where 20% of your revenue is with a single customer or in a single. Now, in our business, we've set it up so that it's very horizontal revenue base that has applications in many verticals. Automotive is about 20%, but we have relationships in customers at the vehicle OEM as well as at the tier ones companies like Continental and Magna and other folks like that are customers of our company. And this technology is useful for lots of other things, from power tools, components being made by people like Stanley Black & Decker in Milwaukee, down to sporting goods being made by people like Adidas and Callaway. So you can make bathroom faucets with this type of technology, right? So we have people like Moen, who's a customer. So it's
Okay.
and then we have people like Lockheed Martin, and they do stuff that we can't talk about. So it's a really cool
Okay.
broad application base, which is
So now, what if you all were going to make a pitch to, say, a company like SpaceX? What would your pitch be for them?
well. I would say that SpaceX does a lot of printed components, and I think that the technology that we've got enables you to do a few things. So we have a powder metallurgy route to printing parts. So this allows you to make parts out of materials that you can't manufacture with laser type of approaches. And it also allows you to make them at much higher throughput and lower cost than what you make them. And when I mean higher throughput is roughly 100 times faster and 1/20th the cost of laser-based approaches, which is the legacy technology. Aerospace is one market where we have not focused early on, and the reason for it is it requires a different level of certification. So an older technology that existed before can get stuck in that industry just because it's already certified. And so we focus on having a very broad set of applications. We focused on things that have rapid adoption, where the economics make sense. Our customers get a payback of less than a year, and they
So you're saying you're not focusing on that area? You're not going to try to get that certification?
No, we have development efforts in medical, which are certified businesses, and aerospace, which are certified businesses. But I would say that if you look at it as a percentage of revenue in the long run, those are not as large of a market, and there is a longer lead time to getting products in. It's going to happen, and it's happening, but it's space is and airplanes. It's a couple of years to get your certifications. So the cool thing is we are less expensive than what people are doing for mass market products, and having economics drive the adoption is a wonderful thing. So we are cheaper than machining and cheaper than casting, and that basically, those are massive markets, and that basically drives adoption horizontally. I'd rather have 1,000 customers growing than like a few customers where you have a long gestation period.
Yeah, no, I think most every CEO would love to have the horizontal kind of opportunity that you all have. On the flip side, what would you say is the biggest risk factor, and what would you say is the biggest challenge that you have to overcome to really get Desktop Metal to where you'd like it to be?
So, I mean, I don't know that I would call it a risk factor. We've got a global, we educate people about a new technology, right? So this is like telling people about computers before they had used a computer before. They were doing bookkeeping by hand, and then all of a sudden they get a mini computer or a PC. And so there's an educational component and the design for the process component to really take advantage of the technology. You want to design for the process. Today, people use our technology to print the same things that they were making before with a different process. They get additional efficiencies if they design for the process. So that is an educational component that is going to take time to educate everybody. The things that I really like about our business that are pretty attractive are we have a high margin recurring revenue business. So a product like our shop system a roughly $290,000 transaction will generate $1,000,001 in revenue over the life of the product and $600,000 in profit. So it's a high margin recurring revenue business. So
Yeah.
similar.
Rick, those don't sound like challenges to me, though.
No, that's
That
true.
sounds
I mean,
like
I was trying to turn your challenge into like the opportunity, but I'd say the we are doing things a little bit different than this industry did in the past. One of the things that we've done that's different than our competitors is we sell through channel. So, like the legacy players that sold these giant powder bed fusion systems, you need a special facility to receive the machine when you install it. And what we focused when we design our systems, like our shop product, is make it really easy to use. So our products fit through a door and plug on a wall, and they're ready to use. They can be deployed through something called channel. Mm-hmm. And so we built a channel now in about 60 countries and growing. And that way you can have local people that can catch an opportunity, support the customer, be able to solve problems, versus sort of the direct sales approach that some of the legacy folks had, where you had a much larger piece of equipment. Sometimes you got to sort of punch a giant hole in a wall to put one of these giant machines in one of these places, and then so long lead time to install, special facilities required, and then they sell direct. And so if you're trying to catch an order in Indonesia or New Zealand, which is really where this market's going to go global, you've got somebody in the Western Hemisphere like waking up in the middle of the night to talk to some customer in another part of the world. It's just not how the business scales. So we want to be global, and we want to have local people in every country where we support our customers and educate them on how to make parts in this new approach, which is much greener and more efficient and less expensive than what came before.
Okay. So it sounds like the problem is desktop metal is so great, everybody needs to catch up and get on your level. Is that basically the only challenge you're facing?
I think that whenever you have disruptive technology, education is the pacing item, right? And eventually so that is one of the, I think people may be used to doing something else, and like inertia is part of it. But it's such a massive market, $12 trillion, right? And today we're at 0.1% penetration. And so this is like talking about e-commerce in 1998. Right?
Wait, 12 trillion is the overall size of what?
Manufacturing market. So we make $12 trillion worth of components and parts and goods every year. And today, most of it is made with conventional manufacturing. You actually make parts in one part of the world because you had some economies of scale that built up maybe 50 or 100 years ago in that location of the world, expertise or raw materials or something else. And then literally you're shipping stuff all over the world in boats, generating CO2 and hurting the environment. And then you assemble those products in another part of the world, and then you ship them again to another component or another part. Whereas with this approach, you basically can print locally, mass customize to a market. You don't have to pay tariffs or VAT. You just do it locally for your application, and then you do final assembly. And it's going to be a long arc. So we have probably 30 or 40 years of growth in this industry. I would say today we're printing parts. In the future, we're going to be printing products.
That brings me to, I think, the last question I'll ask you. I want to end here because I think one worry that folks see when they look at this is great for CEOs and businesses, but what about workers? I mean, do you anticipate that a lot of folks are going to be out of a job because of your technology?
Not at all. I mean, there's plenty of labor in the post-processing or the actual use of these technologies. What it allows you to do is eliminate tooling. And it allows you to have faster cycles. So it makes companies that adopt it more competitive. So if you think of the way you made products before, you had a tool, and then you amortize that tool, which is an upfront investment over many, many, many parts. So here you can make a product without tooling, and it makes a company more competitive. Today you make widgets, and then the world changes, and now you need something else, and you make a different product. So we led an effort. There's a website called printedswabs.org an effort that I set up in the early days of Corona, where we put a lot of the companies that printed polymer technologies to make swabs for nasopharyngeal swabs for coronavirus testing. And we were able to take dental labs that were basically shut down due to the economy, nobody going to the dentist, and we were able to do medically grade polymers and print swabs, and those were machines that 3 or 4 weeks before were printing surgical guides for dental surgery. So you have the flexibility to pivot a manufacturing facility and go from one process and one product to another with no tooling and no capex and no investment. And that flexibility allows you to accelerate your product life cycles. It allows you to develop new capabilities. It allows you to mass customize components to a particular market. And I think ultimately it makes businesses more profitable. There's plenty of folks that work at those facilities making those products. So I don't think you have a labor elimination, you have a tooling elimination. So you eliminate the unflexible part about manufacturing, and you now make it digital instead of analog. Actually, I think what you eliminate is tariffs too.
That's something everybody wants.
Yeah, you don't have to pay tariffs. You print locally, you send the file digitally over the internet, and then nobody pays tariffs on a digital file going over email, and then you make it locally. So
nobody pays tariffs. I think if that was just the company slogan, you guys would sell a lot of these things, and I think people would be really excited about that because I've heard a lot of complaints from CEOs about tariffs. Rick Fulop, co-founder and CEO of Desktop Metal, thank you so much for being with us on Voices of Wall Street.
Dion, it's a pleasure to talk to you. Thank you very much.